This time we have node voltage, the third problem, NP3. Let's start drawing the circuit. We have first off a diamond on the top. The output of this diamond is current in an amount of 3 times I sub A. We will get to see what is this I sub A a little bit later in the circuit. Let's draw the other components. Here is a resistor in an amount of 0.5 ohm resistance, and another fellow here, 0.2 ohm resistance. Here is a voltage source, plus on the top, minus on the bottom, and this is plus on the top and minus on the bottom. We will call this PS2, the second source, and so that will mean we will get to see another source someplace in this circuit. And let's go ahead, draw this inductor of inductance 0.5 Henry. And we have another piece here, which is the capacitance. And here is another source. And on this side we have a resistance in an amount of 0.25 ohm. This goes to join here. So this fellow is the first voltage source is 1. This happens to be 0.1 farad. Here is the ground, 0.5 Henry. And this is I sub A. Alright, so let's recap this circuit, shall we? Well, on the top we have 3 times I sub A as the output of the diamond. And I sub A is the current that's flowing from this node, which is node number 2, onto the floor, which has 0.2 ohm resistance on its path. Node number 1 is here. In between 1 and 2, we have 0.5 ohm resistance. In between 2 and 3, we have 0.5 Henry inductance. And between 3 and 4 nodes, that is, we have PS1, the first voltage source. And let's see, the reference node is here on the bottom. So that should be it. So we got the circuit all complete at this point. The laws that govern the relationship between current and voltage is I sub C for the current that's passing through the capacitance given by C, D, the operator, ddt that is, and Vc. And we can obtain I sub L from Faraday's law in this form, 1 over L, D minus 1 E sub L. Now, if we look at node number 1, we quickly realize that we have a source stuck between node number 1 and the floor, giving us P sub 1 equals PS2. So the target in this problem is to come up the matrix, and we have one box ready to go. Let's see. In this box, we will put 1 V sub 1, no V sub 2, no V sub 3, no p sub 4, giving us what now? PS2. This is to say p sub 1 is PS2. Now, one box is ready. For the remaining boxes, let's go back to node number 2 and apply KCL. So what do we get now? We have 3 branches connected to node number 2. Pth branch having 0.2 ohm resistance, current flows onto the floor given by V sub 2 divided by 0.2. Onto the left, V sub 2 minus V sub 1 divided by 0.5 ohm. And onto the right, towards node number 3, we have an inductance. So we need 1 over L, which is 1 over what now? 0.5 is the inductance, so 0.5. And we have D minus 1, voltage drop is V2 minus V3 equals 0. So let's simplify this fellow. 1 more 0.2 is 5, so it's a 5 V2 plus 2 V2 minus 2 V1, and with the inductance of 0.5, we also get 2 D minus 1 V sub 2 minus 2 D minus 1 V sub 3 equals 0. So that gives us 7 V sub 2 minus 2 V1 plus 2D minus 1 V sub 2 minus 2D minus 1 V sub 3 equals 0. So this is going to give us another box, which is right here. We have minus 2 V1 and we have 7 plus 2D minus 1 V sub 2 plus minus 2D minus 1 V sub 3 plus no V sub 4 equals 0. Let's see, this thing is V sub 4. V sub 4, okay. Hold it. Okay, does it do it? Well, let me try again. This is 4, folks. Okay. Next, we need 2 more boxes, so we will consider supernode 3 and 4. Supernode which we often write as SN 3 and 4. So what we get there is V3 minus V4 equals PS1. This will give us another box ready to go to the matrix. We have no V sub 1. We have no V sub 2. We have 1 V sub 3. And we have minus 1 V sub 4 equals PS1. Alrighty. So finally, the 4th box will be had if we consider the supernode again and apply KCL. So we have current leaving the supernode in an amount of what now? 3IA. 3I sub A plus V sub 4 over 0.2 pi plus P a capacitance of 0.1 farad, 0.1 D V3, and P a inductance of 0.5 Henry. We have 1 over 0.5 d minus 1 v3 minus v2 equals 0. Time to simplify. So this will give us 3ia, all right, plus 4 p sub 4. If we like to express 0.1 as 1 over 10, I think we could. Or we may do that. dv3 and plus 2 d minus 1 p sub 3 and minus 2d minus 1 p sub 2 equals 0. If we wished, we could also express I sub a in the 3ia in terms of the voltage V2. Or, for now, we may leave it just the way it is. I'm talking about we could if we wanted. So now, let's continue this. And so what we have then is minus 2d minus 1 p sub 2 plus 2d minus 1 plus 1 over 10d p sub 3 plus 4v4 equals minus 3i sub a. So it's going to give us another box, folks. Let's start writing in this box. There is no v sub 1, and we have minus 2d minus 1 p sub 2 plus 2d minus 1 plus 1 over 10d p sub 3 plus 4 p sub 4 is equal to minus 3i sub a. So we got all these 4 boxes we need to populate the matrix. So in matrix form, we have the following matrix. Let's see. Let me squeeze in everything right here. Yeah. Need to be careful here. Kind of narrow space. So obviously this is v sub 1. This is the easiest thing to write here. V sub 3, v sub 4. The top row is 1, 0, 0, 0. So that's going to give us vs2. Next we have 0, 0, 1, minus 1. Gives us vs1. Okay. Next we have 0, minus 2d minus 1, 2d minus 1 plus 1 over 10 d, all right, and then 4 minus 3ia. Wait a minute. Or you could have written this as the fourth row, doesn't really matter. In a matrix, we can swap the rows and nothing really changes. 7 plus 2d minus 1 minus 2d minus 1, 0 is 0. Okay, so that will do it, folks. We got the problem solved. Hope you enjoyed it. Have a good one.